Good morning and welcome to today's class. Today's class is a continuation of our previous classes on quadratic equation. At the previous class, we looked at factorization of perfect squares, where we said quadratic equations of the form x squared plus or minus 2xy plus y squared is said to be a perfect square if it can be factorized into bracket x plus or minus y all squared. I gave you so many examples and exercises there which we did solve. In today's class, we shall be looking at making quadratic expressions perfect squares. Now, we all know that it is not every quadratic expression that is a perfect square. And at the last class, we look at how we can factorize those that are perfect squares. But if an expression is not a perfect square, how do you make it a perfect square and how do you factorize it thereafter? So that's what today's class is centered on. Making quadratic expressions perfect squares. We said to make non-perfect squares quadratic expressions to be perfect squares, we should first make the coefficient of the first term of the given quadratic expression a perfect square, then square half of the coefficient of the middle or second term in order to obtain the third term. Why do we square it? This is because the middle or second term of a perfect square is always plus or minus twice the square root of the product of the other two terms. Remember at the previous class where we said x squared plus 2xy plus y squared can be factorized, or is said to be a perfect square if it can be factorized into x plus y all squared. I told you that for this to be factorizable, that the first and the last term must be a perfect square and the middle term must be twice the product of the square roots of the first and the last term. So if this condition is not met, then we have to make it factorizable, or we have to make it a perfect square by just doing two things. One, ensuring that the first term is a perfect square, and then you have to find if the first term is a perfect square, you then have the coefficient of the second term, square it, and that term you get is the third term. So we have an example here for us that we should find the terms that must be added to the following quadratic expressions to make them perfect squares, then factorize completely. So we have two tasks. One is to make it a perfect square and then factorize it. So what is that term? That when added to these quadratic expressions will make them perfect squares, after which we shall be able to factorize them. A says x squared plus 12x, and B 2m squared minus m. So I shall be solving this to teach us how to make a non-perfect square a perfect square. So the two methods says the two steps. One, that the first term must be the first term should be a perfect square, and if you look at it, it's a perfect square. So we have x squared plus 12x. I shall be using two methods in solving this, so whichever that you think is suitable for you, you can go with that. All right, x squared plus 12x. Rule number one, is the first term a perfect square? Yes, because square root of x will give us x. Remember, we said a perfect square is a whole number whose square root is also a whole number. So x squared is a perfect square. Now, what do we do to the second term? They say we should look for half of the second term. So what's the coefficient of x here is 12. So half of x half of 12 now is equal to 6. Square it. Okay, so squaring it, this becomes 6 squared, and 6 squared is equals to what? 36. So therefore 36 is said to be that constant term that when you add it to this expression, it makes it a perfect square. So that becomes x squared plus 12x plus 36. So this is our answer. But the question says we should go ahead and do what? Factorize it. So since we have gotten this, now how do we factorize this? Remember, I said once it can be expressed in the form x squared plus 2xy plus y squared, then this can be factorized to be x plus y all squared. So I'm going to express this expression in this form. This becomes x squared plus, what do I do to the middle term? Divide the middle term by 2. This becomes 2 into bracket 6x plus, express this in index form, this becomes 6 squared. Now, the constant term you have in the bracket must always be equal to the last term. And if you look at it from the expression which I gave you, you discover that we have y in the middle term as well as y at the last term, as well as x in the first and second term. So, having done this, how do we factorize this? This now becomes x plus 6 all squared. So this is the first method you can use in making a non-perfect square a perfect square. Method 2. If you are not okay with that method, method 2, the question says, what is that constant term that must be added to x squared plus 12x to make it a perfect square? So we said let that term be k. So I'll add it to plus k. Let this term be k. And we said when this is factorized, it gives us bracket x plus a all squared. Now, this becomes, let's expand the right hand side. You have x squared plus 12x plus k to be equal to x plus a times x plus a. When you expand what we have on the right hand side, this becomes x squared plus 12x plus k to be equal to x squared plus ax plus a squared. That is, by splitting one of the brackets into 2, using them in turns to multiply the second bracket, and this is what you get. Now let's collect like terms. This becomes x squared plus 12x plus k being equal to x squared plus ax plus ax will give us 2ax, then plus a squared. Now when these have been simplified, we then compare the coefficients. First term for first term, second term for second term, and third term for third term. With that, we'll get to know the unknown k. So if you look at it, x squared is equal to x squared, 12x is equal to 2ax. With this, if you make a the subject of the formula, by dividing both sides by 2x, when you divide here by 2x and you divide here by 2x, you then have x will cancel itself, will go once, and x will go here. This becomes 1, and x 2 into 6. 2 into 12 is 6. So you have it that a is equal to what? 6. That is for the middle term. Then we have it that the k is equals to what? A squared. And a squared has already been given to be what? 6. So a now becomes 6 squared, which is 6 times 6, and that gives us 36, which is same as what we got from method 1. Then you can then go ahead to factorize it and arrive at x plus 6 all squared. So this becomes x squared plus 12x plus 36, which when you factorize, it becomes x squared plus 2 into 6x plus 6 squared, and this becomes x plus 6 all squared. Let's take another example. Example 2, we have 2x squared minus 3x. So you can use any of the methods which I just explained to you, but going by the first method, you say make the first term a perfect square. Now, looking at it, 2 is not a perfect square, but m squared is a perfect square. So how do we make it a perfect square? All you need to do is to divide both terms by 2. So by doing that, you make the first term a perfect square. So when you divide the first term by 2, you have m squared minus, divide the second term by 2, you have 3 over 2m. So you have done nothing to the equation. It still remains what it is. Okay, now I have made it a perfect square. But how do I know it is a perfect square? Because 1m squared is a perfect square, 1 is the perfect square, m squared is the perfect square. Okay, so whenever you have the coefficient of the first term being a constant other than 1, all you need to do is to divide all terms by the coefficient of m squared, or the first term. Okay, now we have made it a perfect square. The second rule says you find half the coefficient of the second term. So this becomes half of minus 3 over 2 squared. So this, when you simplify this gives you that constant term that when you add to this expression, it makes it a perfect square. So this becomes half of minus 3 over 2 is said to be minus 3 over 2 times 1 over 2, and that is minus 3 over 4. Now square it. When you square it, this becomes minus 3 over 4 times minus 3 over 4, and that will give us plus 9 over 16. So plus 9 over 16 is said to be that constant term that when added to this equation makes it a perfect square. So let's add it. This becomes m squared minus 3 over 2m plus 9 over 16. Now the second question says we should factorize it. So expressing it in the general form, this becomes m squared minus, if you divide this by 2, it gives you 2 into bracket 3 over 4 m plus 3 over 4 all squared. So in this case, when this has been expressed, our answer becomes m minus 3 over 4 all squared. So this is your answer. Alright, in method 2, that what must be added to 2m squared minus 3m to make it a perfect square? We say let it be k. So we have plus k to be equal to, now when you factorize this, you are going to have am minus b all squared. Why am? Because the first term has a constant. Okay, so there should also be a constant in the factor. Okay, then minus b, which is the second term. So let's expand. This is going to give us 2m squared minus 3m plus k to be equal to am minus b times am minus b. So when you simplify further, this gives you am times am, you have a squared m squared, plus am times minus b, you have minus abm, minus b times am, you have minus abm, same, then you have plus b squared. Collecting like terms, this becomes minus 3m plus k to be a squared m squared minus, okay, yeah, because when you multiply minus times minus, minus times plus becomes minus, right? So this becomes minus 2abm plus b squared. So we have been able to factorize it and simplify. Let's compare the coefficients. So by comparing coefficients, we have it that 2m squared is equals to a squared m squared. Now when you divide both sides by m squared, you have a squared to be equal to 2. Let's leave it at that. Compare the second term, you have minus 3m to be equal to minus 2abm. Now I want to get the value for a squared, so I'm going to square both sides. So when you square this, it's going to give you plus 9m squared. You square this, you are going to have plus 4a squared b squared m squared. So that you now divide both sides by a squared. Okay, I'm looking for b, so a squared now becomes 2. So substitute 2 for a squared. This becomes 9m squared is equal to 4 times 2b squared m squared. So that this becomes 9m squared is equals to 8b squared m squared. Dividing both sides by 8 m squared, you now have b squared to be equal to 9 over 8. Now the last term is k. K is equals to b squared. So k is now equal to b squared, which is equal to 9 over 8. So 9 over 8 is that term that must be added to make that a perfect square. And I believe that was the same thing we got. Okay, we got 9 over 16. Let's look at it very well. Okay, so k is equals to 9 over 8. So that means that if you have 2m squared, 2m squared minus 3m plus 9 over 8 is 9 over 8 is that term that must be added to this to make it a perfect square, such that if we are asked now to factorize it, you can then make the first term a perfect square by dividing all through by 2. This becomes m squared minus 3 over 2m plus 9 over, when you divide this by 2, you have 16. So that this can be simplified to be m squared minus 2 into 3 over 4 m plus 3 over 4 all squared, which can be factorized to be m into bracket minus 3 over 4 all squared. So You can use any method, any of the two methods that suits you, and you see arrive at the same answer. That brings us to the end of today's class. In today's class, we have been able to see how we can make quadratic expression a perfect square when it is not a perfect square. And remember, I gave you 3 steps to take. That if it is not a perfect square, the first thing you need to do is to ensure that the first term is a perfect square by dividing all terms in the expression by the coefficient of the first term. Secondly, you now find half the coefficient of the second or middle term, square it, and whatever you get is what will be added to that expression to make it a perfect square. Thank you for being part of this class. We advise that you like our videos while you watch. You are also encouraged to use the comment section to give us feedback. How do you feel about this class? If it's positive, let us know. And you can also add 1 or 2 contributions to make us grow, while you are advised to equally share with your friends so that they can also be part of our daily classes. Thank you for being part of this class. But before you go, I would like to give you an assignment. Yes, I have done mine. Let me see how good you are, or how you have been able to pick up. So I'll leave you with this assignment, where you're asked to find a constant term that must be added to make each of the following quadratic expressions a perfect square, then factorize. Okay, it's just same thing as what I did. So I encourage you to also do same by ensuring the first term is a perfect square, and then find half the coefficient of the second term, square it, and add. That is just it. When you do that, it gives you the constant term that must be added to make it a perfect square. So you have about 20 expressions to make a perfect square. So you can just pause the video, copy out the questions, and then solve it. Let me see your solution in the comment section. Whichever you cannot solve, you can call for help, and I'll be there to guide you. So thank you for being part of this class. See you in our next class. In the next class, I shall be solving the assignment I gave you. Okay, so you have to compare it with yours and take the necessary corrections where you must have faulted. Thank you, and do have a nice day. See you.